So when you're doing the induction, mathematical induction, the general steps that you got to do is the first step, that is your verification. So first step is you verify. Now, if I take this example for which is prove that if your z is r cos theta plus I sine theta, prove that z to the power n is r to the power n cos n theta plus I sine n theta. So this is what I have to prove. Now, whenever you're doing an induction, you got to first convert, make sure, understand the language. So here what we are going to do is first verify that is this result true for, let's say, whatever the n values they have given. So sometimes these results are valid for only, let's say, n more than 3 or n more than 5 and so on. So what you do is, in that case, you got to take the verification values for n higher than 3 or higher than 5 in that different context. But here they said that n is a positive integer. So I'm just going to verify for n equals to 1, whether my equation verifies for n equals to 1 or not. So always remember, this is the first step, which is your verification step. Now, when I put n as 1, let's say z to the power 1 is r to the power 1 cos 1 times theta plus I sine 1 times theta. So what we get is z is r cos theta plus I sine theta. So this is definitely verifying that given condition that, okay, this is true for n equals to 1. The next step is the assumption step. So I would say the step 2 that we got to do is you assume that this result is actually true. So this is your assumption step. So assumption is that, okay, this is true for n equals to k, that for any power of where k is a positive integer, this result holds true. So in this case, what we get is z to the power k. Ideally, just replace in this assumption step. What you got to do is just replace n with k everywhere. That's what it is. So r to the power k, now cos k theta plus I sine k theta. So this is what I should get. I mean, if this n equals to k is true. So now this is the assumption step. Now, if this assumption is true, now we got to prove something. What is to prove? So this is to prove. The third step is, what we got to prove is that, okay, if I can use, in general, this is like away from this example, if I'm adding a, let's say, if I'm using a formula, let's say 1 plus, let's say 2 plus 3 plus, and so on. If I'm, let's say, using a formula that it is nn plus 1 over 2, if this formula can be used to find out, let's say, sum of 100 terms, this also must be able to find out sum of 101 term, 102 terms, and so on. So what we do is, now we got to make sure that this formula holds true for n equals to k plus 1. So if this is true for n equals to k numbers, then it must be true for n equals to k plus 1. And according to the condition, what we got is, if I take z to the power k plus 1, it should be r to the power k. This should be r to the power k plus 1 cos k plus 1 theta plus I sine k plus 1 theta. So this is your what I should get. This is to prove. Now, this is the main step, which is I have to derive in order to prove this result to be true for all the numbers. Our next step is that I'm just going to take the left hand side. I'm not going to take both the sides. So my left hand side that I have is z to the power k plus 1. So I'm just going to take this left hand side and prove that this is what I'm getting. And so what I have, my objective is actually to get what I'm putting into the box. Let's say this is what I have to get at the end. So I'm going to take simply now the left hand side, which is z to the power k plus 1, and um, start with the induction part. So if z to the power k plus 1, it should be, I can write down this as z to the power k times z. So now this one is your is something that decides whether you're going to get the full marks or not. So this is the main step I would put. main step. So what we do is now, since I know z to the power k, if this is true, I can replace z to the power k with this, right? So what I get is basically z to the power k plus 1 can be written as r to the power k times uh, cos k theta plus I sine k theta, and times cos theta plus I sine theta, and of course there's r here. So if I multiply r times r to the power k, so I get r to the power k plus 1. So this is I already got now. I have to not get this part. This is something which is a little tricky. So you got to do one thing is you got to multiply these two brackets. So I'm just multiplying cos k theta times cos theta. So cos k theta times cos theta plus I sine theta times cos k theta plus I uh, sine k theta times cos theta plus I square is -1, so I square sine k theta, this is sine k theta, and uh, times sine theta. So I multiply this with this with this, then this with this, and this with this. Okay, now next step is that, okay, I got r to the power k plus 1. Now you would write down, okay, this is cos k theta. Cos theta is the real part, and here the real part is minus sine k theta times sine theta. And plus you take I common, you could write down this as sine theta cos k theta plus um, sine theta cos k theta plus sine k theta times cos theta. Now here what we got to do is now apply the compound angle formulas. So I'll just quickly write down the compound angle formula. So cos A plus B is cos A cos B minus sine A and sine B. And if I got cos A minus B, it is obviously this is just with a plus. Sine A plus B is sine A cos B plus cos A sine B. So now I'm just going to use this one and the third formula, which is here, to prove for my answer. So if you look at this part, it is cos A cos B, there is cos A cos B minus sine A sine B, sine A sine B. So that I can write this as r to the power k plus 1 as it is. This is actually cos k theta plus theta, and plus I times sine A sine cos B plus cos A sine B, sine A cos B, cos A sine B. So this can be written as sine, this can be actually written as sine I times sine k theta plus theta. So if you simply look at what we got is r to the power k plus 1 cos, if I remove k plus 1 common, so k plus 1 theta plus I sine k plus 1 theta. So this is what I wanted to actually prove. So now since this is true for n equals to 1, n equals to 2, n equals to k, n equals to k plus 1, it is going to be true for n belonging to all positive integers. So this carries your 1 mark. So this is how you do the complex induction.